Continuation. Past questions and answers on K 102 2019-2020 session. Question 21. A sample of methane weighing 9.67 milligram produced 26.53 milligram of carbon dioxide and 21.56 milligram of water. Find the percentage composition of carbon in the methane. Solution. Weight of carbon dioxide produced equal to 26.53 milligram. Weight of carbon in 9.67 milligram of methane is equal to weight of carbon dioxide times molar mass of carbon divided by molar mass of carbon dioxide. So, weight of carbon dioxide from the question is 26.53 milligram. Then molar mass of carbon is 12. Then divided by molar mass of carbon dioxide, which is 44. That is equal to, you now multiply 26.53 milligram by 12. That gives you 318.36. Then divided by 44. And the answer is 7.24 milligram. Therefore, the percentage of carbon in methane will be equal to weight of carbon in methane times 100 divided by weight of methane. So weight of carbon in methane is equal to 7.24 milligram times 100 divided by 9.67 milligram. And that is equal to 74.9%. Then question 22. Acetic acid contains only carbon, hydrogen, and oxygen. A 4.24 grams sample of acetic acid is completely burned. It gives 6.21 grams of carbon dioxide and 2.54 grams of water. What is the mass percentage of carbon and hydrogen in acetic acid? To solve this problem, first, the mass of carbon dioxide produced is equal to 6.21 grams. That is from the question. So mass of carbon in 4.24 grams of acetic acid will be equal to mass of carbon dioxide times molar mass of carbon divided by molar mass of carbon dioxide. So mass of carbon dioxide is 6.21 grams. Then times molar mass of carbon, which is 12 grams per mole. Then divided by molar mass of carbon dioxide, which is 44 grams per mole. So you now multiply 6.21 grams by 12. That gives you 74.52. Then divided by 44. Then on doing that, we now have 1.69 grams, which is the mass of carbon in 4.24 grams of acetic acid. Now, the percentage of carbon in the organic compound will now be mass of carbon in acetic acid times 100 divided by mass of acetic acid. So mass of carbon in acetic acid is equal to 1.69 grams, then times 100 divided by mass of acetic acid, which is 4.24 grams. And on doing that, it gives us 39.85%. Mass of water produced equal to 2.54 grams. So mass of hydrogen in 4.24 grams of acetic acid will be equal to mass of water times molar mass of hydrogen divided by molar mass of water. So on doing that, we now substitute the values and we now have 2.54 grams times molar mass of hydrogen is 2 grams per mole. Then divided by molar mass of water, which is 18 grams per mole. Then when you multiply and divide, it gives us 0.28 grams. Therefore, percentage of hydrogen in acetic acid will now be mass of hydrogen in acetic acid times 100 divided by mass of acetic acid. So mass of hydrogen in acetic acid is 0.28 grams, while mass of acetic acid is 4.24 grams. So you multiply 0.28 grams by 100, then divide by 4.24 grams, and that gives you 6.60%. Therefore, the mass percentage of carbon and hydrogen in acetic acid is 39.85% and 6.60% respectively. Question 23. The IUPAC name of H3COCH3 is dash. The answer to that is methoxymethane or dimethyl ether. Question 24. Dash test is used to detect nitrogen, hydrogen, and sulfur in organic compounds. The answer to that is Leisen's test or sodium fusion test. Question 25. Stereoisomerism is broadly classified into dash and dash. The answer to that is structural and stereo-optical isomerism. Question 26. An organic compound with relative molecular mass of 72 was found to contain 66.66% carbon, 22.23% oxygen, and 11.11% hydrogen. What is the molecular formula of the compound? Okay, to solve that, first you write out the relative molecular mass of the compound, which is 72. That is from the question. Then on doing that, you now list the elements that are present in the organic compound. And the elements are carbon, hydrogen, and oxygen. Then you write out the percentage of each of them. Carbon is 66.66%. Hydrogen is 11.11%. Oxygen is 22.23%. On doing that, you divide by relative atomic mass. The relative atomic mass of carbon is 12. So 66.66 divided by 12 gives us 5.56. The relative atomic mass of hydrogen is 1. So you divide 11.11 by 1. Then you have 11.11. The relative atomic mass of oxygen is 16. So you divide 22.23 by 16 and you have 1.39. Then you divide by the smallest number. So you observe all through and you observe that 1.39 is the smallest. So you divide through by the smallest. So we now have 5.56 divided by 1.39 and the answer is 4.0. Then you also divide 11.11 by 1.39 and the answer is 8.0. Then you divide 1.39 by 1.39 and we have 1. Therefore, the molecular formula will be equal to C4H8 and O. Question 27. An organic compound on quantitative analysis was found to contain 40% carbon, 6.7% hydrogen, and 3.3% 3% oxygen. Calculate the empirical formula of the compound. So the solution to that is, first, you list the elements that are there in the compound, which is carbon, hydrogen, and oxygen. The percentage of elements that are present. So carbon is 40%, hydrogen is 6.7%, oxygen is 53.3%. You now divide by relative atomic mass. So relative atomic mass of carbon is 12. So 40 divided by 12 gives us 3.33. The relative atomic mass of hydrogen is 1. So 6.7 divided by 1 gives us 6.7. The relative atomic mass of oxygen is 16. So we divide 53.3 by 16 and we have 3.33. Then divide by the smallest number. So you go through it, you observe that 3.33 is the smallest. So you now divide through by 3.33. So that would be 3.33 divided by 3.33 to give us 1. 6.70 divided by 3.33 will give us 2. 3.33 divided by 3.33 will give us 1. Therefore, the empirical formula of the compound will be equal to CH2O. Question 28. What is the IUPAC nomenclature of OH, CH2, 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 CH, double bond C, CH3 in bracket 2? The answer to that is 5-methyl 4-hexane 1-ol. Question 29. Show the major product, Markovnikov product, for the reaction between CH3, CH2, CH, double bond CH2, and HBr. The answer to that is CH3, CH2, CHBr, CH3. Question 30. Name this structure. CH2, double bond C, methyl, CH, methyl, then CH3. The answer to that is 2,3-dimethyl 1-butene. The longest chain is 1, 2, 3, 4, and methyl group is attached to carbon number 2, and methyl group is attached to carbon number 3. That is why we have 2,3-dimethyl 1-butene. Question 31. Mention any 4 methods of isolating or purifying compounds. The answer to that is filtration, distillation, sublimation, and crystallization. Question 32. Draw the structure of 3-ethylcyclopentene. So this is a cyclopentene structure, and ethyl group is attached to carbon number 3. Carbon number 1, carbon number 2, carbon number 3. So ethyl group is attached to carbon number 3. So this structure is 3-ethylcyclopentene. Question 33. Benzoic acid is a white crystalline powder used as a food preservative. The compound contains 68.8% carbon, 5.0% hydrogen, and 26.2% oxygen by mass. What is its empirical formula? Solution. First, list the elements that are there in the compound. So we have carbon, we have hydrogen, we have oxygen. So the percent of each of them. So carbon is 68.8%, hydrogen is 5.0%, oxygen is 26.2%. Divide by relative atomic mass. So relative atomic mass of carbon is 12. So you now divide 68.8 by 12 and you have 5.73. Then relative atomic mass of hydrogen is 1. So you divide 5.0 divided by 1 gives you 5. Relative atomic mass of oxygen is 16. So 26.2 divided by 16 gives you 1.64. Divide by the smallest number. So you go through it and 1.64 is the smallest. So you divide through by 1.64. So 5.73 divided by 1.64 gives you 3.5. 5.0 divided by 1.64 gives you 3.0. 1.64 divided by 1.64 gives you 1. So to eliminate this fraction, you now multiply by 2. So 3.5 times 2 gives you 7. 3.0 times 2 gives you 6. And 1.0 times 2 gives you 2. Therefore, the empirical formula of the compound equal to C7H6 and O2. Question 34. Draw the structure for 2-ethyl 1-penene. So this is the structure of 2-ethyl 1-penene. This is the longest chain, 1, 2, 3, 4, 5, which is pentene. Then ethyl group is attached to carbon number 2, 1, 2. So ethyl group is attached to carbon number 2. So this is 2-ethyl 1-pentene. Then question 35. Briefly identify the important distinctions between a saturated hydrocarbon and an unsaturated hydrocarbon. The answer to that is unsaturated hydrocarbons have double or triple bonds and are quite reactive, while saturated hydrocarbons have only single bonds and are rather unreactive. Thank you for watching. Please remember to subscribe for more materials. Thank you.